In this video, what I'll be doing is reviewing composite functions. So we've kind of seen composite functions when we've used the chain rule in calculus. So remember, if we've got a function, say f of x equals g of h of x, then what we've got here is an inside function and an outside function. What we were doing was substituting the inside function and then getting our derivative. Okay, so basically this is what a composite function is. So given two functions, f of x and g of x, it's often possible to perform one on the other, and what we're doing is creating a new function. We call that a composite function. So this notation here, f of g of x, basically we're just saying f can operate on g. And the alternate notation, which did come into the study design at the start of last year, is this. So f, and there's this little circle here. Probably that circle should be more central. F, G, X, like that, with a little circle there, not down the bottom. It usually sits in the middle. And so I've heard people refer to that as fog. Okay, it's not an O. Student asked today, is that an open circle for an interval? It's got nothing to do with intervals either. Okay, so that's just a notation saying that we're forming a composition f of g of x. All right, so g can operate on f, would take the notation g of f of x, and we would write goff. F can operate on itself, f of x, so that would be foff. And lastly, g can operate on g of g of x, and that would be gog. Okay, so be comfortable with an alternate notation. Question could be asked or ask you to do this, and that basically is just saying find a composite function which is g of f of x. All right. So there's some rules that we use to form compositions. So for f of g of x to be defined, the range of g of x must be a subset of the domain of f of x. So what that basically is saying is when you give x values to g of x, what we'll call the inside function, okay, what will happen is it will convert them into y values. Okay, so just say I did g of 2, it might say the answer is, I don't know, -6, for example. Okay, now for this composition to work, -6 needs to be accepted by the domain of f of x. Okay, so just say the domain of f of x, for whatever reason, was 0 to positive infinity. Okay, this composition is not going to be defined because g of 2 is -6, the y value is -6. It goes into f of x. Okay, and f of x domain is 0 to positive infinity, so it says, no, I'm not taking that value. So that would be an undefined composition, or a composition that we can't form at this stage, is what we'll say. So this notation is used to check that, and I'll be using that in the examples, but this symbol here means subset. And we can use not subset by just slashing the subset, a bit like kind of not equals. Okay, so this is not a subset. So if f of g of x is defined, then the domain of the composition is just the domain of the inside function. And again, I'll be going over why that's the case in general, and also there are some cases where this is not true, and I'll address why this is the case. In general, f of g of x is not equal to g of f of x, except in one circumstance, except when if we've got f of x, then g of x is equal to f -1 of x. So if g of x is the inverse of f of x, then the composition will work both ways. Okay, so that's going to happen when they're inverses of each other. All right, so let's head in and do this. So state the rule for the composition and the maximal domain for which the function is defined. Okay, so with these problems, I always state work out the domain and range. So we can see here that's a parabola over all reals. So that is going to be a parabola moved up 1 unit. So its domain is all real numbers. Its range is going to be 1 to positive infinity. So the turning point upwards. Okay, g of x is a linear, domain all reals, and range all reals. Okay, that's just something that looks like that, basically. Okay, so what we're going to check is whether the composition can be formed by checking whether the range of the inside is a subset of the domain of the outside. So I'm just going to write that down. Ran of the inside, so the range of G. Now let's find out what it is. Here it is here. It's this. So I'm going to put that in brackets as all real. And I'm just going to write subset of the domain of F, which is all reals. Now, is this true? Okay, so all real numbers is certainly a subset of all real numbers. Okay, they're the same thing. So this composition is going to work. All right. So now that I know it's going to work, all I'm going to do is form the composition. So I'm going to say that f of g of x is f of, now g of x is 2x plus 1. So I'm going to replace g of x with 2x plus 1, which basically says wherever you see an x in this, replace it with 2x plus 1. So I'm going to go 2x plus 1 squared plus 1. So there's our composition and its domain, where x is an element. And so all we're going to say about the domain is that it's going to be the domain of the inside function. Because this one has to accept the value first, it'll simply be its domain. All right. We know that its domain is a set of all real numbers. So we're going to say x is an element of all reals. Okay, state the rule. All right, I better just copy these. I'm just going to grab that. All right, so this time I'm going to do g of f of x. So that will be g of, now f of x is this, x squared plus 1. So we're going to put that in here, which is 2 brackets x squared plus 1 plus 1. So replace x with f of x. All right, its domain, where x is an element. Now let's just check whether this composition is going to work. Okay, so I'm going to add a line off to the side here. The range of the inside, so the ran of f, has to be a subset of the domain of G. So let's just check that. What was the range of f? I'm going to scroll up to my original table. The range of f is 1 to positive infinity. The domain of G is all real numbers. All right, so what we're saying is this a subset of all real numbers? Well, absolutely it is. Okay, this consists of the numbers 1 to positive infinity, and this says I'm all real numbers. So that is definitely a subset of that. So the composition works. When the composition works without modification, we're just going to say that the domain of the resulting composition will simply be the domain of the inside function. And that was the parabola, and that was also defined over all reals. Okay, find the range for each of the composite functions in parts A and B. So I'm just going to do this within the question. Okay, so let's go back to this first one. Now the composition we formed is this one here, and I just need to know its range. So if x is an element of all reals, then the parabola is going to be true for all reals. Now these values in here will shift this parabola half a unit to the left and 1 unit up. So that's what the parabola is going to look like. So we're just going to say y is an element of, now the lowest value is 1, the highest value is positive infinity. Okay, for this one here, that is 2x squared plus 3. Alright, so this is a standard parabola, moved 3 units up, dilated 2, we're not really worried about the dilation, but 3 units up. Okay, so we're going to say y is an element 3 to positive infinity. So that's our range. Alright, so answered in A and B. All right, so not too bad for that first one there, and this second one, because I just did this in class today, I know that this one works out quite nicely as well. Okay, so state the rule and the maximal domain. Okay, so again, what we do is we get the domain and range of f of x and g of x. So this parabola here is, let's put that into turning point form. Okay, so I know the domain is all real numbers, but it's range x squared plus 2x plus 1 squared. There's my perfect square. Take away 1, take away 3. Equals x plus 1 all squared, take 4. So this parabola here moves 1 to the left and 4 down. And it's an upright. So I can see that the range is -4 to positive infinity. Okay, g of x is the standard exponential function, and what happens is the standard exponential function looks like that. This one's been moved a half a unit to the left. Okay, now that does not have any effect on the domain, which is all real numbers, and it doesn't have any effect on the range either. The range is still going to be 0 to positive infinity. That 0 should not be square, it should be rounded. Okay, so now that I've done this, let's do f of g of x. Let's see if the composition can be formed without modification. So I'm just going to say the ran of g, which is this, 0 to positive infinity, is a subset of the domain of f, which is all real numbers. Now let's just check whether that's true. Okay, yep, 0 to positive infinity is a subset of all real numbers. So the composition works. So again, let's do the same thing as last time. Let's go ahead and form the composition. So f of g of x is f of, now g of x is the exponential, e to the 2x plus 3. That basically means anywhere where you see an x, we're going to change it to e to the 2x plus 3 squared. Then plus 2, then take away 3. Now this we're going to use just the power to power rule, which basically says this power raised to that, you multiply these together. So e to the 2 bracket 2x plus 3 plus 2 e to the 2x plus 3, take 3. You could expand this one here, but I don't think it's necessary. Where x is an element, so because we haven't had to do any modifications to domains to get the composition to exist, all the domain is going to be is the domain of the inside function. So that's this one here. That's standard exponential, so it's going to be all reals. All right, still going. So we're going to do the composition the other way around. So just so I don't have to scroll around too much. Grab that, paste it in down here. Okay, so we want to do this composition. For this composition to work, I need to check something. So I'm going to check whether the range of the inside is a subset. Let's just write it out. So range of the inside, here's its range, -4 to positive infinity, is a subset of the domain of the outside function, which is all reals. All right, so is that a subset of all reals? Absolutely. So we can go ahead and form the composition. So we're going to say that it's going to be g of f of x, where f of x is this, x squared plus 2x take 3, equals e to the 2 brackets x squared plus 2x take 3 plus 3. Clean that up a little bit. E to the 2x squared plus 4x take 6 plus 3. Oh, I probably should have done that step in my head. Where x is an element. All right, so again, what we're looking for is the domain of the inside function, which was f of x, and f of x had a domain of all reals. So that's going to be the domain of the composite function. Okay, so on to the third example now, and this is where it gets a little more tricky. Okay, so this one here, what we're going to do is go domain and range f of x, g of x. So do this every time. All right, the domain of f of x, the linear, is -infinity to 3. And its range, well, let's just quickly draw it. So 3 goes in, it produces 0. Negative gradient means that it flicks upwards like so. So we can see that its range, lowest y value is 0, highest y value, positive infinity. Okay, now g of x, domain or reals, range -1 to positive infinity. So uses the TP. All right, now let's just check whether this is the case, that the range of the inside, so we need ran of g is -1 to positive infinity, is a subset of the domain of f All right, so what you'll notice here is this one here is -1 to positive infinity. This domain here is -infinity to 3, okay? So this is a problem because this one can produce values to positive infinity. So it can produce 300, it can produce 5,000. Now the issue is that this one will accept only a value as large as 3. So we're going to say that this is not a subset, okay? Now, that doesn't mean that we can't form the composition, but what we need to do is actually kind of tweak it so that the composition will be able to be formed. And what we're going to do is try to restrict this range so it's only going to produce values from -1 up to the highest value acceptable, which is 3. So, to do that, what I do is I grab g of x, which is this parabola here, and what I say to it is, okay, for what values of x are you going to be less than or equal to 3? All right. So I'm going to go x squared take 4 less than or equal to 0. Now what I'm going to do is factorize that and sketch the inequality. Right, and what we can see here is it's less than 0 between these two values here. This is when y values are less than 0. This is when y is equal to 0. This is when y is greater than 0. So it's this part here that I'm interested in. I'm going to highlight that. It's this part. So for this part here, what it's going to do is produce values that are less than 0. And in turn, basically, if it's going to do it for that, in turn, it's going to apply to this, which means that these are the values for which x squared take 1 is less than or equal to 3. Okay? So this is going to ensure that the function will never produce a value that is outside of the domain of the outside function. Okay? So now we know that, what we can do is form the composition. So we're going to say that f of g of x, so f of, now g of x is x squared take 1 equals, so x squared take 1 goes into the linear 3 take x squared take 1, which is 3 take away x squared plus 1, which is negative x squared plus 4. So there's our composition. Now it's where x is an element. So typically what we've done is just found the domain of the inside function. Okay, this one here. and we can see that the domain of the inside function is all real numbers. But this time we can't use all real numbers because all real numbers produces this range here, and this range here will not be completely accepted by this. Okay, so we know that it's going to be less than 3 for values between -2 to 2, and that is going to be our domain. So we're going to say that only for values between -2 and 2 is this composition going to work. Okay, so this is again the first scenario in our notes where the domain of the composition is not the domain of the inside function, and the reason for that is we can't let that happen. We can't let it be all real numbers because then it's potentially going to produce an out of domain solution. All right. So pretty hard that, and a tough concept to understand. All right, that's it for that one. All right, so example 4, okay, state the rule for g of f of x and the maximal domain. Okay, so again, to do this, what we're going to do is dom ran f of x, g of x. Okay, f of x has a domain of -infinity to 0. Now its range, that's an x squared parabola moved up 1 unit, -infinity to 0. So that's like that, 1. So it's going to be 1 to positive infinity. Okay, the linear, -2 goes in, gets negated, and becomes 2. 2 take 2 is 0. So -2, 0. 2 goes in, that's -2, 2, -4. There it is there. So I can see that its domain, well, that's -2 to 2. And its range, lowest value looks to be -4, highest value 0. Okay, so state the rule and maximal domain. So for the composition to exist, the ran of f, let's find out what it is. So the range of it is 1 to positive infinity. For this to work, it has to be a subset of the domain of the outside, which is g. So it has to be domain g, and that's -2 to 2. Now that's a problem. So this produces values from 1 to positive infinity. This only accepts values between -2 to 2. Okay, so this composition is not going to work in its current form. So we're going to use the same approach as last time. We still want to form the composition, but what we've got to do is make some restrictions. Okay, and the fact is that this function here, the inside function f of x, okay, we need it to not go to positive infinity. We need its range not to be positive up to positive infinity. In fact, what we need it to be is less than 2. Okay, and so we need to change this range so that it goes like that, 1 to 2, and then this will be a subset. Okay, so what we're going to do is the same as last time. We're going to go 2x squared plus 1 has to be less than or equal to 2. Has to be less than or equal to this value here. All right, let's go ahead and solve this. So 2x squared, take 1, less than or equal to 0. Now if I solve this, all right, I could use difference of 2 squares on that, but actually it's just a parabola with intercepts at -1 on root 2 and 1 on root 2, and it's an upright parabola, so that's what it looks like. Okay, so we can see here that it's going to be less than 2 between these values here. Okay, so that's when it's going to meet these requirements here. Okay, so let's form the composition. So we're going to say that g of f of x, g of, now f of x is the parabola 2x squared plus 1 equals negative 2x squared plus 1, take 2. Now we're probably going to clean that up a little bit. Negative 2x squared, take 1, take 2 is take 3. So there's our composite function. Now what we're going to say is where x is an element. Okay. Now we can see here it starts producing values less than 2 between negative 1 on root 2. Okay, so less than or equal to, so that's fine. So we're going to accept negative 1 on root 2. And it looks like it's allowed to go up to 1 on root 2. Okay. Now the only problem is that if we look at the original domain of this function here, it actually is from negative infinity to 0. Okay, so actually what we need to do is terminate this graph at this point here. This part here is not relevant. So it's going to be from negative 1 on root 2 to 0. And will it accept 0 itself? Yes, it will. So that's going to be a square bracket there. All right. So as I said in class today, this is probably as hard as it gets. Okay. So see if you can have a good, careful think about that as you do this problem. Okay. State the rule for f of g of x and the maximal domain, which the function is defined. So let's do ran g, which is the range of g is negative 4 to 0. Has to be a subset of the domain of f, which is the domain of f is negative infinity to 0. Oh, did it include it? Yep. Okay, so we can clearly see that negative 4 to 0 certainly is a subset of this. Okay, so that is true. So we can form this composition straight away. So f of, we don't need any modification because it's immediately acceptable. So we're doing f of g of x. G of x is the linear, negative x take 2. So that goes on for every instance of x, which is 2 brackets, negative x take 2, all squared, plus 1, I think. Yeah. Okay, let's just clean that up. So 2, let's go brackets, negative comes out, x plus 2, squared plus 1, square that and square that, so the negative just basically cancels out because negative 1 squared is 1. So we've got 2x plus 2 all squared plus 1. Where? Okay, and again the domain, because we didn't have to make any modifications, the domain of the composite function is going to be simply the domain of g of x. So the domain of g of x is negative 2 to 2. All right, so there it is. All right, so attempt those 1E questions, okay, yeah, think about it, okay, really think carefully about how this all works, it does take a while and it does take persistence, but once you kind of see it and see how it works, really there's no or not much variation in the questions that examiners can ask. Good luck.